Hey, what's going on, everybody? Welcome to the Spotify technical interview question. My name is Richie Nunez. I'm the events and media coordinator over at Outco. The very first thing that we're going to do actually is launch a poll. If you are a job seeking software engineer and you'd like to join a community of like minded folks, please feel free to answer yes to the poll that was just launched. I'll leave that up for a little while. We're going to jump right into the event overview. We got a lot to cover. First and foremost, welcome. You could be watching Netflix, you could be eating dinner with your family, but instead you're here dedicating yourself to the betterment of you. And so, congratulations and thank you so much for your time. We're going to be doing a quick intro to Outco, to myself and to Surf for 5 minutes. And then we're going to be jumping right into the Spotify technical interview question demo with Surf, which is going to take about 45 minutes or so. And then we're going to be ending with a quick Q&A for about 10 minutes. If you don't know, Outco is a 4-week career accelerator that's built specifically for software engineers. And what I'm going to do actually is end this poll and launch a second poll. If you find value throughout this presentation, I wanted to let you know that we actually have a Black Friday special that's going on. It expires tomorrow at 6 p.m. Pacific Standard Time. It's 20% off of all upfront payments. And so I'll leave that up as well. If you're interested, select yes, and we'll send you some more information. Outco was founded in 2015 in San Francisco. It's essentially a coaching and skill sharpening service that's built specifically for software developers. We've helped over 2,000 software engineers land their dream jobs. And if you're interested in joining us, we actually offer classes in Eastern Standard Time and Pacific Standard Time as well. I again am Richie Nunez. I'm the Outco Events and Media Coordinator. I'm also the Outco Alumni Community Manager. I've managed over 50 events for Outco having to do with software engineering negotiation, resume optimization, whiteboarding, etc. And Surf, I'll let you introduce yourself.
Hey everybody, my name is Surf. I'm a technical lead. I've been in the industry for about 11 years. I've worked at a couple of companies that are probably in your phone. WeWork, Venmo, PayPal, and I'm now leading the commerce engineering team over at Spotify. I have a wealth of knowledge. I have a master's degree in computational data science, and I'm also a teacher over here at Outco. And I just love sharing my knowledge with like minds that are trying to learn about software engineering.
And without any further ado, we're going to be starting the Spotify technical interview question demo. I'm going to launch this last poll here. If you find value throughout this presentation and you want to learn more about Outco, please join us for an Outco info session to select the days and times that you're available. Surf, I'll let you take it from here.
All right, let me share my screen. Cool. All right, so everybody should be able to see my screen. Make sure that's correct. Hey, let me stop this share. It looks like it's not working. Cool. All right, let's get into it, right? Everybody should be able to see me draw. All right, so the goal of today is what happens if you walk into an interview and you see someone who looks like me, and this is the technical interview time, right? So you walked into an interview. I'm sitting there. The first 5 minutes, we kind of do that ditty that me and Rich just did. You tell me a little bit about you. I'm going to tell you a little bit about me. First 5 minutes out of the way. For the next 40 minutes, we have to solve a question, right? And the question is, build a play stream service. Cool. And then I stopped talking. What would you do? Well, at that point, your job is to figure out ways to understand exactly what I mean by a play stream service, right? So your main job and your main goal here, and you're going to start seeing me write things in different colors. Anything that I write in red means you need to memorize. Your job is to ask questions. That's the entire goal of this interview. We want to understand your ability to go on a fact-finding mission and uncover complexity, unbox complexity, because this is a job interview like about leveling, right? It's what is your appetite to dig into something that is unknown and turn it into something that can be known, right? So the main job that you're supposed to be doing is asking questions, and you're asking questions for a specific subset of reasons. So one of the questions that I would ask in that scenario was like, okay, what do we mean by play streaming service? And then they'd give you some more hints. Ideally, I would give you a hint to be like, okay, cool. It's something like Google Analytics, right? Or something like Spotify, right? Like what happens after you hit the play button, right? So like I'm pretty sure everyone's heard about like the music industry and how like streaming is destroying the music industry. But exactly like what does it mean to be a stream, right? It's like you hit play on Spotify, we collect the fact that you hit that play, and then at the end of the month, we pay Drake, we pay Alicia Keys for all of the plays that have happened on the platform. And I think one stream is equal to 6 cents. So for Drake, he gets millions of streams. We take the amount of streams, the amount of money, multiply those two things together, and then we cut Drake a big fat check, right? So that's what we're trying to build, the service that allows us to aggregate that data, right? To be able to say, hey, you got this many plays this month, here's your check, right? So we're asking questions to figure out exactly what the size of that system really needs to be. And what we're actually trying to understand is, back to red, 4 fundamental things that allow us to build a system that sufficiently answers this problem. We want to understand the use cases, right? Well, okay, cool. You said play stream. What actually happens? Like what parts of the play stream are we actually talking about? I click play. What are the steps that happen? What do the users see? What do we need to see? What do we need to show? Right? The use cases are going to unmap the ERDs. So the entity relationship diagram. So these are basically like, okay, if I said something like, hey, we're building Facebook and I need a user to log in. Log in is the action, the entity is user. That means we need like a user table, or we need some sort of user data structure, right? That's an entity. And if the user has something like photos, the user can be related to those photos. So that's what this means. It's an entity, the relationship diagram. Diagram. Right? That's what ERD stands for. Then the next thing we want to figure out is, okay, I understand the use cases. I understand how I want to mock this data, right? The last piece is, okay, cool. Well, how big is the service, right? How many users are we talking about? How many users does Facebook have? What? 100 billion? Or how much users does Spotify have? 367 million, right? Like we need to know these numbers to see how sufficiently big our service needs to be, right? And we call those the estimations, constraints, and the bottlenecks, right? You have to take all of these things into considerations to make sure you're building a system that is sufficiently large enough to handle this amount of throughput, right? And the last thing is the actual diagram. We just call it scaling, right? Making sure that your diagram represents the bottlenecks to use case and the entity relationship mappings, right? So you walked into this interview with me. I say, build a stream service. Your next question is, okay, cool. What part of the stream service do I have to worry about, like playing the audio? And then I'm like, no, it's actually after the click. Like when a click happens, we need to know that in real time, right? So when I say that, it's your job to pull that information and then actually start writing it down. So let's start. We're going to go on the first part of our journey, use cases. All right, cool. So the first one is we need to collect user play button. Play button clicks in real time, right? So as soon as you hit click, I need to know about it. All right. The second part is we want to show artists their plays in real time, right? So when you click on play, if Drake is logged in, he can see a number go boop, right? That a user is playing right now at that second. And if there's multiple users playing his songs, that number should be bigger, right? So like if he logs in, he can see this thing in real time, right? And then the last one is we need to generate a consumption report monthly. Cool. Wow, what a consumption report is how many plays did Drake acquire in this month? We need to calculate that as a number for all of the artists so that we can cut them checks, right? Because they want to get paid, right? And like those are all of our use cases, right? But it's your job to go in there and ask questions to get me to say these things, and then you write them down, right? So like that's the first part of the process, understanding our use cases. Now that we have our use cases, right, we can step into the next part, which is our entity relationship diagrams, right? Well, let's look at our use cases. What would be an entity? An entity is something like an object or something like, let's say, a noun, right? Well, we have these concepts of users. We have this concept of artists, right? And then we have this concept of like some sort of report, right? But it doesn't need to be something that we map. It's like, it's really the data journey and like what we need to understand, right? So we have this concept of like these clicks and these plays, right? And that's really what we need to understand. We need to understand like when a user clicks on something or when it plays, right? Like we need to store all of the data associated with that, that action, right? So like for this specific example, right, we're gonna mock around the user implementation. We're gonna mock around the clicks and the plays. But a great question to ask is, okay, cool. Do I have to worry about a user being logged in? And I'm gonna say, no, right? For our use case, the user's logged in, right? Like when you're logged into Spotify, you're logged into Spotify. If I'm on the play strict team, I don't care about login. I don't need to know anything about emails or passwords, right? I just need to know that your user ID clicked on play for this song for this artist, right? And that's essentially like my data and the thing that I need to care about and I need to store. Now I'm going to pause here. If anyone has any questions, if you can chime them into the questions and answer section, that would be great, because that gives me a little bit of space to answer your questions over time in a more question answer format. Let me double check chat real quick. Okay, cool. So please, if you have any questions, ask them, because I'm going to go through a lot of information that's going to be kind of crazy really, really quickly. Is this database NoSQL or SQL? That's a good question. Ask it in the answer and questions portion so that I can give everyone the answer. I will answer this one for you. No, it is not, right? Because this isn't the section where we start talking about our database, right? And I'm going to actually give you a further answer. This doesn't require a database for us to solve it, right? The decision on NoSQL, SQL, some other database abstraction really comes from another part, which is the consumption level, right? Can a database, right, handle the same amount of throughput as a pub sub technology? No, you're not. If we're talking about writing at the scale of 1 million writes a second, right, we probably aren't going to use a normal database architecture, regardless of if it's NoSQL or SQL, right? So again, the database talk might be a little bit premature, right? And we'll start uncovering that once we get through it. So here's what I would say to that as the last talking point on that, right? You shouldn't start talking about if you're going to use a database until you get to here, right? That's when you start talking about database. Cool. All right, Mohammed. And again, yeah, ask those questions. So answer question, would like to answer this question live. Oh yeah, so the answer to this question, I don't know if I just speak it, it's kind of interesting, is no. You don't worry about what database you're using here. You wait till at least step 3 so that you can understand the constraint, and then we can start talking about databases. Cool. Answered that one live, hopefully recorded. That'd be really cool. Cool, sweet. Let me get out of this. All right, so back to the ERDs, right? So we need to mock up what this is, and then we need to create some sort of consumption report, right? So the things that as my team we need to understand this play stream. This play stream needs to understand, well, what the song is, potentially who the user is, what the artist is, and maybe the exact moment in time, right? Because there's like real time versus monthly consumption thing that we need to understand, right? So let's break that out. Let's call our entity a play stream, right? Well, we know we have the user who's logged in, so we can get a user ID. If the user is logged into Spotify and they play a song, right? We know what song it is and we know what artist. So that probably means we can get the song ID and the artist ID, right? Then what's the last thing that we think we would need there, right? Well, most likely the timestamp, right? Because we keep having this concept of like real time versus monthly, et cetera, et cetera. So we know exactly when you played that song. And in theory, this is all you truly need to mock up our PlayStream service. And this is like roughly really close to exactly how we do it at Spotify, right? Like we want to know the user, we want to know the song, we want to know the artist, we want to know when they started to play, and then when they ended the play. And those are two timestamps that we like retrospect to see if like the window was long enough. We're not worrying about the windowing technique right now. We're just saying anytime you press play, that counts as a click. Now, an interesting thing that is a segue, and this is why I'm going to write this in blue, is I want to show you what it would look like if we were mapping this as an entity, right? Let's say that we had to worry about a user logging in. There would also be a user table, right? And this is only in the world where we cared about logins. We don't. I just want to show you what it would look like and what you would be learning when you decide to come hang out with me in Outco about like entity and relationships and their mappings, right? So now if they have a user table, we know that we have to have user login. We have an ID, we have an email, we have a password, right? This ID maps to this user ID, right? So the question is, if I am a user, how many songs can I actually listen to? Many. So that's a many relationship. That's the direction that goes this way. If I am a song on the play stream, right? Like if I am one record, how many users could have like generated me? Well, this ID is a one-to-one mapping, right? Like only one user can be the owner for this specific play of the song, right? Because the timestamp and the ID around that is going to be unique. So it means that I'm always going to be owned by one user. And this is a one-to-many relationship. It's basically saying if I am a play stream record, right, I am owned by one user, but if I am a user, I can generate many play stream records, right? And now we're going to erase that because that's not actually into our use case. It's just me showing you how to do the relationship part of the entity mappings. But for our use case, it's simple enough. We only have an entity, right? So let's bump back. Cool. Entity diagram out of the way. Now we need to start getting into the constraints themselves, right? All right. So we know we have users, right? We can leverage, again, knowledge that we already previously had of users and clicks and things to ask interesting questions, right? If I says we need to collect user plays, anytime a user clicks the play button in real time, an interesting question might be, well, how many users do we have? How many songs do they listen to, right? And those questions are going to prompt me as the interviewer to start giving you some numbers and some factual bases, right? So like we know how many users are on Facebook, right? It's like, I don't know, they have 100 billion active users. We actually know that number for Spotify. We have 360 million active monthly users, right? So the fact that we said we want to understand users, right, every time they hit the play button, right, or every time they play a song, right, is very indicative of the types of question that you should ask. So the questions that you should ask here to understand the estimations are how many users, how many songs do they listen to? And then that pulls that out of me, the interviewer, because again, that's your entire job, is to keep asking questions to pull information out of me so that you can understand the system that you need to build. I saw one question there. Oh, I see two questions there. Yeah, so multiple users can listen to the same song. All right, let me answer this. Click it. Multiple users can listen to the same song at the same time, right? But if the users are mapped to their own user ID, then that's fine, right? It should come up as two indistinct records at the same time. That's fine. So we are targeting the global audience, but we're not reporting based on geographical location, right? And at Spotify, we also don't care about the The geographical location of the user. Well, oh, I didn't even hit answer. Let me answer this. At Spotify, we don't care about the location of the user who played your music, right? As long as they played your music, you're getting paid for that, right? So like, yes, this is launched to the global audience because it's going to be the number of all of our users, and that's fine. But like, in our reporting that gives you the money for the consumption report, it doesn't matter if the person is in Nova Scotia or the US, we're paying you the same amount. So good question there. Is there ever an expectation that we make assumptions about the estimations instead of no, I'm glad you asked this. No, do not make assumptions, right? If you have, if you want, even if you want to make an assumption, what I would say is, okay, can I assume this? And say it to the interviewer, and the interviewer will say, okay, that sounds about right. Or they'll tell you, oh, your assumption is wrong, because we're actually coming in there with a fact sheet to actually like give you facts to say, hey, no, the numbers actually look like this, because we're expecting you to get roundabout some sort of synopsis of the same answer, because again, we ask these questions to multiple people in these interviews. Okay, what about the same song playing on 2 different devices at the same time? Do you mean someone who's like logged into their phone and their iPad? Cool. So that's a great question. Let me answer. Can I answer both of them? Oh, so if a user is logged into the same phone twice, let's say we'll keep that, right? So let's say that'll just be 2 records. So that will effectively account as, actually, no. Well, yeah, let's say that counts as 2 records, right? So that would, for us in this limited use case, because there's a lot of things that we kind of have to solve, let's say that that would count as 2 records. So yes, you can spoof this system. If you had, I don't know, 100 iPhones, you could account for 100 plays on the consumption report. And again, like, if you're really thinking about it, if we're paying 0.006 per stream, it's like negligible at that range, unless you had an ability to spin up 1 million servers and like actually spam our system, and then we can build in like anti-intrusion monitoring to do that, and we're not going to handle that here. It's fine for our use case. So cool, good question. Sweet. Does a play have to be? Nope. We're not worried about that. We're treating this as a click stream. So let me answer this one again. We're treating this as a click stream, right? So we're saying as soon as it hits play, that counts. In the real Spotify context, there is a time window. I can't really tell you what that time window is, because then like people can figure out how to game the system. But it does require both a play and an end play. So what we do is we actually take 2 events. We click it when you first start to play, and then if you pause or if you skip, we add another one, and then we take both of those to figure out the total window of your lesson, and then we decide if that counts as a play or not. I just can't tell you what the actual length you need for it to actually count as a play. Cool. But in our use case, we only worry about the first one. We're only worrying about the start events. We don't care about the end event. Cool. Good questions. All right, I will carry on. So now you looked at your use cases, which again, you were supposed to, once I'm telling them to you, you write them on the board. So they're your guide, right? They helped you write the ERDs, and now they're helping you ask questions about the consumption. So your question is, okay, how many users do you have? How many users do you have? And I say something like this. We have 3, this is where it gets fun and it gets really crazy. We have 300 million daily active users, right? 300 million daily active users, and they listen to about 50 songs. Cool. Your thought here is you're always going to get some metric in the daily or the monthly form, right? Because like these are how these reports normally get written. When you hear about Facebook's growth, right, you hear about it from an M&A perspective, monthly active users, right? Like that's what they show, those hockey stick growth charts. And that's how all these startups acquire all this funding, right? Like everyone loves the monthly figures because it's a large enough time windows. But as an engineer, we do not care about the monthly figures, right? Like we need to know, a better time format, ideally the second to second traffic, right? So that we can build a system that can like handle it at that level. So we have to do these conversions. So what I'm going to do is I'm going to give you a little trick, right? I'll write this in red because it means another thing that you can memorize. 500 million anythings, doesn't matter if it's users, clicks, whatever, a month is approximately equal to 200 anythings per second, right? And it's math. The math always holds true. If you divide 500 million, right, by 30 times 24 times 60 times 60, you'll get a number around 214.16, yada, yada, yada. So in tech, we've just summated, right? So it's a summation, it's an abbreviation to 200, right? So now that we have that number, we can basically say anything that's an interval of 500 million, right? We can turn into 200 of those things, right? The only problem here is we have daily, right? This is in the monthly context. So simple math, all we have to do there is first multiply. I have some questions. I'm going to answer this math out real quick to show you how simple it is to like get from this 200. So again, remember, memorize this 500 million to 200, right? We do the first multiplication. So we get 15,000 million, right? Which turns to 15 billion. Billion daily, right? 15 billion again. Remember, this is daily, right? I'm going to take the monthly approximation there, right? And we know that 500 million into 15 billion goes 30 times, right? So I multiply this number right over here by that 30. So I get 6,000, right? And this is those anythings a second. But remember, this is monthly and that's daily conversions. So to turn it back to daily, right? Like to turn this daily back into like the monthly figure or the monthly estimates, I would have to multiply this side by 30 because that's the part that's missing. Like this is in daily. So to make it in monthly, I just multiply it by 30. So now I get, right? 0 here, and then 3, so 18. So now we have 180K, and that's a second, right? So that's a lot of data. We're saying we're doing 180,000 events a second. All right, I'm going to stop here, and I'm going to answer questions. Wait, what's happening? Why can I get? Oh, here we go. QS. Can we simplify the numbers so instead of using 300 users, we can simplify to 300 for the interview calculations? I mean, the reason why we said 300 million is because they're going to give you a number that is sufficiently that large. And the way that I've given you a quick summation right here, right? So like now we know that 500 million, right, is going to be equal to 200, right? So now we can take that and we can do the quicker multiplication. So you can actually take this into all of your interviews and just use that to kind of do these flips. Okay, where did the 15 billion come from? 15 billion what? Okay, cool. I'm going to answer that one too, right? So right here we have 300 million daily active users, right? And each one of them listens to, on average, 50 songs a day. So if you take this 50 and you multiply it by 300 million, right, you get 15 billion daily song plays, like actual song clicks, because each user listens to 50 songs. Sweet. Exactly. Perfect. Yep. I had each user listening to 50 songs. But again, this is how they're going to give you that format. They're going to just give you these large numbers, and then you have to do some conversions to turn them into seconds. And the quickest way to do those conversions is take this 50 million anythings a month, knowing that that equals 200 of those a seconds, and then you kind of dance around daily, monthly, and all these different transformations. But again, like this 500 million answers sufficiently most of the questions, because they normally give you things in the hundreds of millions of area or buffer space. Cool. Sweet. So now we have where is it? All right, now we have our estimations, right? So the estimations also tell us what our constraints are, right? If we're talking about 180K a second, we probably can't just stuff that into a database, right? So if you put a database on that, on your scalability drawing, right, you're gonna have some problems there, right? You're gonna actually have to really explain like what you're going to do to kind of solve and get around that bottleneck, right? So it's showing us our estimations, and based on those, we have to understand what the constraints and what the bottlenecks are going to be. Why do we care about seconds? So we care about seconds as engineers, right? Because we need to know the throughput that the system needs to be able to handle at any given point in time, right? So like the monthly estimate is so large that building a system to the monthly estimate, right, because the numbers are so large, don't make sense. But if you think about it, if someone told you that you had a system that was like 500 million users doing one action a day, right? Then you know that the action is also 500 million, and then that turns into 200 of those actions a second. Your system doesn't need to be as big as a system that's doing 180K a second. So the reason why is like that second, like the amount of traffic or throughput that we're handling a second, right, allows us to understand how big the system needs to be, or like where the potential gotchas are. So I'll give you a better example. A database can potentially handle 200 writes a second. It cannot handle 180K writes a second. Cool. Well, specific database can. Some can, some can't. We'll get into that once we start drawing out the diagram. Cool. So now we're at the last piece. This is the happy space, right? So now we're talking about what actually happens when you click that play button, right? So you've logged in to Spotify, you've searched your Now Weekly, and you see a song and you hit play. What happens, right? So I'm a user, and I hit that play button. Something happened. Let me see, was there another question before I dig in? So, come on, Zoom, why do you keep doing that? Okay, cool, no questions. Cool, I hit play. On my device, I hit play. My phone, my laptop, I hit play. We need to write that record, remember, in real time to us. So I'm going to give you the answer here. It's going to be very tough for me to explain all of the pieces, but like once we build everything out, then you're going to probably ask questions in the Q&A sections, and then we'll get into the question and answer section and we'll start talking about it, right? But remember, these click events are apping it at 100K a second, right? So the first thing in our infrastructure you're going to hit is the load balancer. And the whole job of the load balancer is it's a single point that is elastic, so it can like scale up and it manages how traffic comes into it. But it can also, it collapses our IP address range because it is a proxy, and it allows us to scale up our infrastructure behind it to handle any throughput that it's seeing, right? So here we're talking about multiple users, right? Clicking play all at the same time. We're talking about 180K of people playing songs all at the same time, right? Going into the load balancer, and the load balancer is distributing the load between multiple application servers. App. Right? Cool. So this is taking that 180K and distributing it against, let's say, 10 nodes. So each node is now seeing 18K. So each node is now fine. But they still have to pipe this data into something that can handle 180K's worth of load, right? So what we do is on the side of that application server, we put producer code. right? So that we can write all of these to some sort of message queue system. So in this instance, we're going to call that pub sub. And I'm sure for questions, right? So we're taking all of these messages as fast as they come, and we're dumping it into a pub sub so that we can like hold and house this data in some sort of temporary storage before we actually like decide like what we're going to do next, right? And this fundamentally answers this problem, right? Which is we need to collect user play button clicks in real time. Once it's here, we've collected it. It doesn't mean that's all of the journey, but you need to think about your use cases as I'm solving each use case at a time, right? So this allows us to, you click the play button, we've now stored it in a, again, temporary, this is a temporary facility, right? This is a temp location. And the reason why it is a temp location is because a pub sub cannot hold, is not a permanent data store, right? It can store vast amounts of data that is very, very large, right? As a passageway for, on default, 7 days. If we're talking about Kafka, if we're talking about Google Pub Sub, right? It is not meant to keep this data forever. How is the front end passing data to the back end? Great question. So when you click on that button, right, you're just sending an API request that says, I am this user, this is the song, this is the artist, this is the timestamp, right? And I'm sending that as a, let's say in this scenario, post request to some endpoint, right? That is like behind a load balancer to the API. So that's a good call out. So ideally, let me step back a little bit. Do I have time? Yeah, I can answer that one, right? So we're saying we have a post to our play stream endpoint, right? And the post body is going to be user ID, song ID, artist ID, right? And that's what we're sending. And then maybe the API appends the timestamp before we send it on to the pub sub, right? Is load balancer running on a separate server than app servers and they transfer data along? They're not running, well, they are running on a separate server, but you don't have to think about like you manually configuring that. So a load balancer is something that you'll get for free from AWS or GCP. But yes, they are running on separate servers. So yes, that's why they're detached. Your load balancer is in a completely separate space than your application servers. So that's good. So wait, hold on, let me get to that. So we're using a pub sub here because we have 180,000 requests a second. You can't just directly store that in a database. And remember, the storage and the first response have to be real time. Okay. When the data gets to the pub sub, how does the system respond if the queue fails? What happens if what happens to the data stores in the queue? If the queue fails. Okay, cool. So redundancy is part of the thing that is built in and should be built into the infrastructure and the build out of your pub sub technology. So again, the pub sub should be sufficient piping for the throughput that you're putting into it, right? So a pub sub failure in that manner means that you just didn't actually create a sufficient space for the pub sub. And let me give you a better example to that, right? So how many messages can Kafka read? Cool, right? LinkedIn, that's the actual team that created Apache Kafka, and they can do, they've run a test where they can do 2 million writes a second on 3 cheap machines, right? So again, as long as you build the piping sufficient enough, you can manage 180K. But again, 180K is more than you can potentially solve with normal RDBS technology. Done. What data format is JSON and what auth is being used? We don't care about auth. Remember, it says that user is logged in. That's the login team. We are the play click stream team, right? So like we don't care about auth. We just need to know that the user is logged in, right? Well, we don't even need to know. We just want to know the user ID of the person who clicked. We don't care about that. But the format that we are transmitting is JSON. So this is done. This is done. And I'll do one more question and then I have to start finishing up the lecture. Cancel, live answer, done. We need a pub sub cluster to handle the number of requests. Pub sub cluster isn't the right terminology. There we would say we have a bunch of topics and a bunch of partitions for our pub sub. So we don't think of pub subs as clusters. So like that's why it might be a little bit different when we're thinking about the amount of load, but pub subs are built to handle those loads. And the way that we do it is partitioning. Oh, this is another good one, right? Again, it's not sharding in the normal terminology of a database. When you shard a pub sub, it's you add more partitions. So yes, but that should be something that you configure because you know the estimation itself, right? The estimation was 180K, so your cluster should be big enough to handle 180K and some overflow. So you should probably make it big enough to handle, let's say, 300K. So does the request go from front end to the load balancer, and then the request flows from the load balancer to the app server? That is a yes. We can't expect one pub sub instance to handle all global data because you have one for each data center. So you need to aggregate all of the data across different pub subs. That I would say is a negative. You can have one pub sub that handles all of this data globally. We do for Spotify. Right? Because again, I think the interesting thing that we're not thinking about here is we're thinking of one pub sub as like just like one pipe. But actually, when you configure it, it's again multiple partitions and multiple pipes, right? So it's like I would say that a pub sub should be configured to be a pipe that is the pipe that sends all of the water to a city, right? Like the pipe that sends all of the water to your house from the city is a giant pipe, but it can actually pipe out all the water to everyone in the city, right? So like that's the pipe that we're thinking about when we're thinking about the pub sub technology. We're not talking about little pipes, we're talking about really, really big pipes. And again, if you read here, 2 million writes a second on 3 machines, right? So again, the technology is built to be sufficient enough to handle that load. All right, I'm gonna dig back in and I'm gonna start breaking out the last pieces, right? Cool. So we're back to here. We've solved this piece. Now we want to show the artist in real time, right? So we've got the data in real time. We haven't really talked about how we're going to show the real time second to second data, but it really requires the artist. I'm going to put here on this artist, right? To say that this is an artist. Right, this is an artist. Now logs in. Oh no, that's not good. Now logs in, there we go, right? To some web front end, right? So this is load balancer, this is the application server, and this is like the web front end, right? So this is when you log into Google Analytics, right? But then when you click on the live stream, it shows you this bar, and then every time a new user comes to your webpage, it like bumps. And if 2, it bumps higher, right? That's what we're talking about. For that to happen, right, we need an either push or pull technology where the app is refreshing every second, or we're using something like a WebSocket, right, to push data through from some other load balancers, right, with other application servers behind it that have consumer technology, right? These are the things that read off of the pub sub, the events that are happening, and do windowed aggregations. So a consumer every second reads all of the things that happened in that second and then starts partitioning it. If something wants to see that data, it either pushes it to them, or that thing, when the user logs in, it can pull it from the consumer, right? But the consumer itself is, again, a part of the code on the application servers for this serving side, right? So this helps us answer the question of, okay, cool. Artists can also see like the real-time graph of just like, okay, cool. Second by second, I can know like if people are listening to my music, right? So that solves that second problem. But remember, we said that the pub sub is a temporary store. It can only hold up to 7 days worth of data, right? So like we also need a permanent store, but the permanent store answers a different question, right? So the permanent, I'm going to answer the rest of the questions at the end of the lecture, just to make sure that I can finish. So we want to show the artist, right, their plays in real time. So what we just built answers showing them their plays in real time. But the last part is like, well, we need to generate a consumption report for the monthly, right? And the pub sub can't hold monthly data. It holds 7 days worth of data. If the message hasn't been read in those 7 days, then it basically kind of just gets kaput, right? It gets erased. And then the record companies would sue us as Spotify, right? Because we're actually fudging the numbers at that point and we're not paying people out properly, right? So the last thing we want to solve is, wait, what's happening? Oh, there we go. The consumption report. Well, ideally, it actually goes through a different flow. For us to generate the monthly consumption report, it means that we need to aggregate every single play that happens over a month. And if we're talking about 180K, right, happening a second, right? Well, how many seconds are in a month? A whole lot, right? There's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and 30 days in a month, right? So you take that number, multiply it by 180K, you get back to what? It was our 15, well, it wasn't even 15 billion. It'd be 15 billion times 30, which is 100, which is 450 billion clicks a month. We have to aggregate that now to figure out, of all of these plays, how many did Drake get? How many did Alicia Keys get? How many did whoever your favorite artist get, right? Break those apart and then start paying all of those individual artists out, right? So for us to do that, we need some other technology that can do this aggregation and that can hold this data. Well, we can still take the consumers, right? And say, hey, consumers, we need you to write this data, but we want you to write it in another capacity. We need you to write it to a distributed file system or something like Hdfs. Hdfs, right? It's the Hadoop distributed file system, right? And basically what this is it's a system that you can actually just write everything to these files. And all of these files are held on distributed architecture and distributed systems, right? So let's think about it like this. Let's say we had a card game and you gave me a deck of cards and the deck of cards has, I don't know, 52 cards in it. And you asked me to sort it, right? You shuffled it up and you wanted me to sort it in like, a specific order, right? Like you wanted me to like logically group everything and like get it into like the correct order. As one person, I could do it in a minute. What happens if you gave me 3 other friends and we split the deck into 4? Which one would be faster? The one person working by himself or the 4 people working at the same time? The 4 people working at the same time, because we just parallelized the task. That is literally what HDFS does. It basically says, I have an army of computers. I'm going to store parts of the data on all of these computers. And then when asked to do something like a consumption report, I'm going to say, all of you computers, sort your data. And they're all going to sort their little piece, right? Come up with their numbers and their tallies. And then they're going to say, hey, pass it up to the manager. Hey, here's my answer. Here's my answer. And then they're going to aggregate all of those together to give you an answer as quickly as possible. It's called like many hands make work light, right? So like that's the process that HDFS solved for us. And what that really means is HDFS runs a Hadoop MR job. It's called the map reduce job. And the map reduce basically means I want to map things and I want to reduce them so I can do aggregations over time over large clusters of data. And then the last part of that is, okay, now we have this. This we can use to actually generate our report to pay our artists, right? Because like the result of this is we run this map reduce job to find all of the plays for all of the artists, tally those numbers up, and then we multiply it by the payout, and then we start cutting them checks, right? So this is all on an offline process, right? Of like how we generate a report or how we generate payouts. So with that, I'll wrap this up. The last part I would want to say is that seems a little bit magical. So I really want to break home what I mean when Hadoop can handle this, right? So I'm showing you this picture. This picture is of the world's largest supercomputer, and it's called Summit, and it is at Oak Ridge National Labs. Now, the reason why I know this to be true is my professor, Chase Wu at NJIT, for intro to data science, he actually worked at Oak Ridge National Lab. He did his PhD dissertations there, and they do Hadron star collisions at Oak Ridge National Lab. They simulate that, right? So Summit, right, is a supercomputer that has 9,216 22-core CPUs in it, 27,000 NVIDIA Tesla GPUs in it, right? And it can process 200 petaflops of data, right, a second, right? So if you think 180K a second is big, this is 200 petaflops of data a second. The computer actually takes up 3 stories and an entire building. That's how big this computer is. So again, this is massive processing power because again, they're talking about doing exaflops of data, right? Because they're doing genome sequences, they're doing hadron star collisions, right? So like this is big, massive amounts of data, right? And if you could think about it, like when Google is sorting all of the information on the internet, they also have like rooms filled with data centers of servers to like do these aggregations. And the Hdfs system is actually something that came out of Google. So they have a lot of white papers on exactly how Hdfs is designed and how they use it to actually generate all the things that you see when you go into google.com and you do a search query. All right, cool. So that's it for this portion of it. I think we now bumped into the Q&A section. So I'm going to answer these questions and then we'll start talking. Where would you learn about all these technologies to know when to use them and when you are creating architectures? Well, I've been in the industry for 11 years and I'm still learning. So the short and skinny answer of that is like, you'll always keep learning. Part of that journey is, hey, join me at Outcome. I'm going to teach you some of the things that I know. And I learned them over both trial and error and having a master's degree where I learned from really great professors on how to handle these sorts of problems, right? So like what you kind of gain in that scenario, right, is you kind of gain me and my experience and me sharing that stuff with you. And again, like as you start working in the industry, you'll start meeting other people as well to learn more about these really complex architectures. Why not use something like BigQuery to store and further aggregate the data? Yeah, so actually, that's a good question. BigQuery is designed off of HDFS. So Google actually built HDFS first, and those white papers are the things that led them to build BigQuery, right? So yeah, you can use BigQuery here. Again, it does similar-esque things. BigQuery, another example of that was you could use HBase, because I think BigQuery is NoSQL. I might be right or wrong on that, but HBase or Cassandra is also a distributed version that is also NoSQL-esque. So you could use that as well. But again, remember, the main reason why I use HDFS, right, was because this is a completely offline query, right? And if we're storing it in files, it's going to be the cheapest storage that we can potentially have. All right, where can I find some sample design, flowcharts, key terminology used in software design? I have a mechanical. I'm a visual and kinesthetic learner, so I tend to like, you don't have to search a lot of this stuff on YouTube. I think that's one of the best ways to kind of learn this stuff. But if you look up like Hadoop architecture, Kafka architecture, those things, you could find a lot of it on YouTube. So that's a good one. It's different based on the position you applied for. This is probably more a, let's say, data engineering question, but I could actually see a world where we ask this to a front-end engineer, right? Like, I mean, not a front-end engineer, like a full stack engineer, just like thinking about how they think about complex problems, right? Because it's not really about you getting the right answer. It's about your ability to unbox the unknown, right? So like like again, somebody said, oh, you could use BigQuery there, right? Like that's a great call out. You can, but it's because BigQuery has Hdfs styled properties, right? So like, in a sense, this could potentially be asked on any of the interviews at Spotify. I would say yeah. Like I'm not specifics on the BigQuery of it all. I feel like we use BigQuery. Let's see, BigQuery. Oh, BigQuery is okay. I have a better answer for you now. BigQuery is, I guess, their warehousing solution. So I would say it's similar to Redshift, right? In what is it? In AWS, right? And yeah, you could potentially store it here. What I will say is these are actually stored on live nodes, and if it's Postgres, right, like you're potentially probably paying more for this than you're paying for HDFS. So yes, you can, because again, when we're talking about massive amounts of data, we're talking about database warehousing technology, right? Like this is very specific to, okay, BigQuery is like a Google specific thing, right? So like I've never used BigQuery. Most of the companies I've worked with are on AWS. So we would use Redshift to do something like this, right? But again, we could eke out much better cost and performance boost using HDFS. But yeah, you could use BigQuery to solve that last part too, as well. How does HDFS run Hadoop? And that's more of that's a harder one for me to answer. You really have to understand Hadoop infrastructure and architecture in and of itself. But it's great that you asked that. I can give you this beautiful 400-page read on exactly how that works. So, oh no, I wish you could ask that question again. I'll just ping it into the chat. That's my bad. Chat. Cool, it's in the chat. Thanks. No problem. Yes is the answer to that. Yes, I'm not using a database at all because our use cases don't specifically call us for a database, right? The consumption report is something we generate offline monthly to pay people out. So I'm using an offline technology, HDFS, because you can't actually strap that into an endpoint because of the way that it actually reads files and returns other files, right? But again, we don't need that. Our use case is, can you generate a consumption report so we can know the numbers so we can pay these people? How is the level determined? Well, it's really your level of understanding and and like the things that you know. So the fact that like I brought up things like Hadoop and you're talking about solving things with BigQuery and Redshift, it shows that you've been around the block and that you understand how to do these things. So it's really based on like your understanding and your ability to both pull out the requirements and the things and the terminologies that you use and understand in the interview. What level would these interview questions be for? These interviews are asked for all levels, but they're used to gauge your level. So if you're coming in, let's say, and you're quoted as a junior, right? But they ask you a question and you solve it at the mid-level, you may actually get bumped up, or you may, in the potential, actually get a pay raise, right? Because like there's, again, when you come in, yes, certain questions are asked to certain levels, but again, the way that you answer the question and like the amount of knowledge you have, they may actually start changing that when they come in and ask you the second round or when they come in and ask you the next round. So it's used to gauge where you should truly be in the company. Would this question be something that would be asked for a Spotify interview currently? Ooh, yeah, I could see that. Because again, like you're coming in as a CS grad, and we need to gauge the knowledge of the school that you went to. So again, I learned a lot of this stuff about Hadoop from that teacher, but again, I took my master's degree, right? So I'm supposed to be learning that kind of stuff. So if you're going in for like a research position at Spotify, 100% they'll ask you this depending on your research background. If it's just undergrad in CS, again, we could still ask you this sort of question. I have never given or heard of anyone actually being asked the cost of the infrastructure from a like actual dollars and cents perspective. When you start talking about should I use caching versus should I use databases, there is one cost you need to keep in mind that caches store things in RAM, databases store things in hard disk. Hard disk is significantly cheaper than RAM. So you can't just say, I'm just going to store it in Redis, because for some use cases that might not be practical. Focus on breadth of technology tools or general problems. I would say general problem solving skills and a breadth of higher level technologies, right? So you kind of saw how I went into it and I was like, okay, we're going to call this pub sub. A pub sub could be Kafka or it could be Google pub sub. And kind of to that other point, right? Like we could use Redshift or we could use BigQuery. You should just call it data warehouse. Like talk about it in the most generic term. Would you ask this to any engineers? I would ask this question to both backend engineers and data engineers, 100%, because I would expect this to be an easier one for data engineers, a harder one for backend engineers. But like, again, if a backend engineer could get it, I could be like, okay, this person is like, that person's down to like be a senior or to like be a tech lead on some projects because like he gets the thing. What would be more junior version of the answer to this question? No. I mean, this is the answer to this question. If we wanted to talk about a more junior version, it would probably be just a completely different question. But again, I would still ask this question to a junior, but because again, the goal of the interview is not to get that specific answer. The goal of the interview is to see, okay, you are seeing something that you don't understand. How do you unbox complexity, right? Which is, again, the number one goal in this entire thing is keep asking questions, keep asking questions, keep asking questions, right? And they'll get you as close as you can to some solution. Maybe you put a database and then they're like, okay, a database can't work here. What can you do? And then you start talking about sharding and stuff like that. And they're going to be like, okay, this guy really doesn't know how to solve this problem, but at least he got here. Maybe he's a junior. Because again, this interview isn't pass fail. This interview is, okay, you are stumped. Are you going to ask me questions to try to unstump yourself? The moment you clam up, that's when you fail the interview. The information that we were putting in the pub sub was this stuff right here, right? Well, right here. Oh, Lord. Keeps happening to me. Was this information right here. So the pub sub literally got user ID, song ID, artist ID, and timestamp. So like all of those fields as one record every time you hit the play button. Sweet. I have some questions in chat. How can I get the recording? I think Richie's going to help you out with that, maybe. Oh, he answered these questions. Rolling up service, taking numbers. Okay. Richie, are you here? Can you hear me?
I am.
We are done. So,
right. And I just wanted to reemphasize that all registrants will be receiving a recording of the event. And you can actually go to our YouTube channel and you can see all our past recordings from all our events as well. And actually just wanted to give that friendly reminder that if you did want to find out more about Outco, we still have our poll going. Be sure to join us for an Outco info session. With that, we're going to be ending the event. Everyone, thank you so much for being here. Surf, do you have any final words before we sign off here?
Hey, this is the beginning of a journey, regardless of if you hop on it with us or if you're just like, again, I think one person was like, I'm an undergrad in CS, right? The one thing that I will say that will help you leagues in this industry is patience and persistence. I've been in this industry for 11 years and it took me 11 years to teach you some of the things that I'm teaching you right now, right? So like whenever you get frustrated, buckle down, have a nice cup of hot cocoa, and just sit by the computer and just keep getting cracking. It will pay off dividends in the end.
Awesome. With that, we're going to be signing off. Everyone, thank you so much again for your time. And I hope you have a beautiful evening. Take
All
care.
right. Bye, everybody.